Welcome to Thermal Engineering Lecture Series. In this video, we will learn how a petrol engine works using an Otto cycle. The Otto cycle is a basic cycle for a petrol engine. Also, it is a ideal thermodynamic cycle. It explains how heat from the fuel combustion is converted into mechanical work. The cycle has four processes: adiabatic compression, constant volume heat addition, adiabatic expansion, constant volume heat rejection. These four processes repeat continuously while the engine is running. The pressure volume PV diagram shows how pressure and volume changes during the cycle. The area enclosed by the cycle represents the net work produced by the engine. Let's look at each stage. The cycle starts at stage 1 where the piston is at bottom dead center. The gas occupies its maximum volume and has lowest pressure. At this stage, piston moves upwards. It compresses the air-fuel mixture without exchanging heat. This is an adiabatic compression process. During compression, the volume decreases while the pressure and temperature increases. This is the path from stage 1 to stage 2. At stage 2, the piston reaches top dead center. The gas is at its minimum volume and its pressure and temperature are very high. Next, fuel is injected. Heat is added very quickly while the piston remains almost stationary at TDC. Since the volume stays nearly constant, this is called constant volume heat addition process. The pressure rises sharply from stage 2 to stage 3. At stage 3, the gas reaches its highest pressure and temperature. The energy released by the combustion is now ready to produce useful work. The gas then expands, pushing the piston downward. This is the power stroke where useful mechanical work is produced. The expansion occurs without heat transfer, making it an adiabatic expansion process. As the gas expands, the pressure and the temperature decreases. This is the path from stage 3 to 4. The area under the expansion curve represents the work done by the gas, while the area under the combustion curve represents the work required to compress the gas. The difference between these area is the net work output of the cycle. Stage 4. The piston returns to bottom dead center. The gas expanded and cooled. Finally, the heat is rejected at constant volume while the piston remains stationary. The gas pressure decreases, returning the system to state 1 and completing the cycle. This cycle repeats inside the petrol engine, converting the heat released during combustion into mechanical power that drives vehicles. Although it provides a clear understanding of how petrol engine operates and helps to improve engine performance and efficiency. That's it guys. Thank you for watching.